Hello everyone. So today we will be finishing up section 8.7. So to recall, yesterday we learned how to solve logarithmic equations, and for the first topic today we are going to take it a step further and we are going to solve logarithmic equations on both sides. So just remember, like yesterday either you just like a single logarithm, or if we had multiple it was already on one side. So now we're just going to look at when they're on both sides. So same thing as yesterday. So with these, when you're just solving logarithmic equations, we're still going to be using these steps. So let's go ahead and get started. So when I look at this, we want to solve log base 5 of x plus 6 equals negative log base 5 of x plus 2 plus 1. And our goal is to solve for x, right? So step one, we're going to isolate the logarithm. So yesterday when we learned how to isolate, we just moved around some numbers. Now we're actually going to have to move around some logarithms. So in order to determine which logarithm to move, usually if there's a negative, I'd like to add it, so just adding. But another thing is, notice that there's a third term here, which is a positive 1. So essentially, I'm just going to get this coefficient by itself as well. So instead of having to move two terms, we're just going to move one term, which is the log base 5 of x plus 2. When we do that, we get log base 5 of x plus 6 plus log base 5 of x plus 2, and that is equal to positive 1. Right? So step 2, we are going to write a sum or difference of logarithms as a single logarithm. So as you can see, that there's an addition here, right? And we have the same base. So when logarithms have the same base and there's addition, then we can use the product property, which I'm pretty sure is property 5, right? So what does that mean? So if I have two logarithms with the same base and they're adding, I can make it into a single logarithm, right? And then we just multiply the arguments. Right. So going back to the steps, right? So over here you have a couple of options. If you want to FOIL this out right now, you can. But what I like to do is I like to get rid of the log first, so it's just less to worry about, like less chances of forgetting to write something, because we all know, like I do it too, sometimes we drop something, so it's better to just deal with less. So what are we going to do? We are going to write this in equivalent form. So log base 5 of x plus 6 times x plus 2 equal 1. We can rewrite this as 5 to the first equals x plus 6 times x plus 2. Right? 5 to the first power, that is just 5, and then x plus 6 times x plus 2, that is x squared plus 8x plus 12. Right? 6x plus 2x is 8x. Right? So I see this x squared, so this is a quadratic. All right, so since it's a quadratic, I know I'm going to have to get one side to equal to 0, so we can factor. The reason why we want it to be 0 is so we can use the zero product property. If we stayed at this step, there's no way to know what x is, because there could be so many possibilities over these combinations to get a positive 5. Right, the zero product property is really nice because we can get one factor to equal to 0, and we know that the whole thing is 0. Right, so let's subtract 5 over. Okay, and the reason why I'm subtracting 5 over is because I'm looking at this leading coefficient. It's positive. Since it's positive, I'm just going to subtract this over, right? So I don't have to deal with a negative, or we don't have to factor a negative out or anything. Right? So with x squared plus 8x plus 7, when I factor this, I can get x plus 7, x plus 1. Right, using the zero product property, I know x plus 7 is equal to 0, or x plus 1 is equal to 0. Let me get more space. So what do we know? X is equal to -7 or X is equal to -1. So now, our final step. So now we found what X was, but these are potential solutions. Okay, potential solutions. So what do we have to do now? We have to check our answers, right? So let's check X is equal to -7. So I'm just gonna copy this down. Okay, so it's easily there. And I'm gonna add more space here. Right. So looking at this original equation, when I plug it in, I get log base 5, and then -7 plus 6 is this equal to negative log base 5 of -7 plus 2 plus 1. Okay, when I solve within the parentheses, I get -1 is equal to negative log base 5 of -5 plus 1. Right? So again, what are my restrictions for the argument? The argument, going back up here, so argument in this case is x. X has to be positive. Right? No if, ands, or buts. So in this case, this is -1, this is less than 0, -5, this is also less than 0. Since both of them, so it doesn't even matter if both of them are it. So this one could have been a +5, but this been a -1. That automatically tells me, that x minus 7 is not a solution. Okay, so yeah, it does not have to be both. It could have just been at one of these. All right, and it's still not a solution. So x minus 7 is not a candidate for a solution anymore. So now let's look at x is equal to -1. So when I plug that in, so I get log of 5 and then -1 plus 6. Is this equal to negative log of 5, base 5 of -1 plus 2 plus 1? Right? So when we solve, we get log base 5, and then this is a 5. Is this equal to negative log base 5 of 1 plus 1? Right? So I'm looking here, 5 is greater than 0, 1 is greater than 0. So therefore, x equals -1 is a potential solution. So let's take it a step further and let's continue solving this just to make sure we didn't mess up anywhere else. So log base 5 of 5, that is 1, right? Remember, because of property 2, okay? And then log base 5 of 1, so with any type of base, if the argument is 1, this is 0. So this is -1 times, I'm just going to put -0, so it's -0 plus 1, right? But what is -0? It's 0. So we get 1 is equal to 1. Okay, this was property 2 and 1. Right, so 1 is equal to 1. So therefore, what does this tell us? This tells us our solution is x equals -1. Right? So now, let's do one more example. So one thing I want to correct over here says solve for x. Technically, this is not x, so it should actually say solve for the variable, right? But it doesn't matter. So in this case, we're going to solve. So our variable in this case is h, right? So same steps here. But one thing I want you guys to notice is there's only logs here. There's 3 individual terms, and all of them are logarithms. So you could isolate. So this could be a log of -3h, and then you could also subtract the negative minus log of 2h minus 15, and then you could have equals 0. Then you could have found a log of negative 3h over 2h minus 15, right? But that's just a lot of work, all right? So we're not going to do it that way. The difference between example 1 and example 2 is that there's a term here. All right, there's a constant here. Since there's a constant, we have to always isolate them. But when we see something like this, we can actually use another trick. So let's go ahead and let me show you what I mean. So says isolate the logarithms to one side. So step 1, it's a little wishy-washy when we just have logarithms. All right, so I'm going to go ahead and go to step 2, and I'm going to write this sum of logarithms as a single logarithm because they both have the same base, which is 10, right? And this is adding, so what am I going to do? I'm going to use the product property, which states if they have the same base, then I can multiply the arguments together. So this is log, and then negative h times 3 is negative 3h. Okay, and then over here it stays the same. All right, so now what do I mean? So instead of rewriting our equation in exponential form, one thing we could actually do is use the equivalent logarithm expression or something. I don't remember the technical name. I think it's like maybe it's called equivalence of logarithm expression. I don't know. But what it states is that, so it's a logarithm if they both have the same base, which they do because they both have a base of 10, right? What does it mean? That means that the arguments are equal to each other. So therefore, negative 3h is equal to 2h minus 15, right? Because they have the same base, right? They're both logarithms with the same base. That means the arguments are equal to each other, right? So now let's continue. So I'm going to subtract 2h over when I do that. So negative 3h minus 2h, that is negative 5h, equal to negative 15. Remember, we want a coefficient of positive 1. So this is 8. So if we divide both sides by negative 5, negative 15 divided by negative 5 is positive 3. So remember, the very last step when you have so a thing about logarithms, square roots, you always have to check it, right? Because they have domain restrictions. So for h is equal to 3, we're going to check. Right? So we have log of negative 3 plus log of 3 equal to log of 2 times negative 3 minus 15. Right? You can go ahead and solve this argument right here, but honestly, you can stop right here, right now. Why? Because of this negative 3. Okay? This one is not within our domain, so therefore this doesn't work at all. So therefore, not a solution. Right? Since this was our only potential solution, right, and then we found out it's not a solution, what is our only option then? Our only option, so there is not a, or actually not a, no solution is our solution. Right? And that's it for topic 1.